Hello guys, let's find the general solution for this integral right here. Ax to the power n minus 1 by bx to the power 2n plus minus k, where a, b and k are constants. Now, this is the crazier or the tougher part to the previous integral without the a and b. Now, for the first step, let's just take this a outside, so it becomes x to the power n minus 1, b x to the power 2n plus minus k. Now, from this point, you can proceed in two ways. First is by taking b common, so that becomes x to the power 2n plus minus k by b, and here k by b will just be another constant, which if you want, you can let it another constant, but you can proceed as your own wish. But I'm going to do a bit crazier method. What I'm going to do, dx of course, what I'm going to do is, well, you can write x into 2n as xn into 2, right? Obviously. And here what I'm going to do is, well, raise x to the n to the power 2, or simply xn square. And this b right here, I can write it as square root of b whole square. So in fact, we can skip some steps, and here a into m into b into m will just be abm. So here, this will simply be square root of b into x to the power n whole square plus minus k. Because if you open this, you'll get b x to the power n into 2, which is just this right here. And now we can let u is equals to square root of b x to the power n. And then we get du equals to square root of b into n x to the power n minus 1 dx. So we have this part right here in the denominator, and all we require is square root of b into n. So let's just introduce that right here. And to not change this integral, we have to divide by square root of b into n. So this becomes a outside, I'll write the n forward, n square root of b square root, and this whole part is the du part right here, and this is the u square plus minus. Now we can write k as square root of k whole square. Now from this point there will be two cases due to this plus and minus sign. I would have started off with an example, but we have done so many examples, not of this but of previous videos, and I just want to get forward with a general solution right away. So let's start with our case 1 when we take this positive sign. So this becomes a n square root of b, this will be outside, du u square plus root k square. Now this will be equals to a n square root of b, and here this integral part right here, it will be equal to 1 by whatever this constant is into the tangent inverse of this variable by that constant. So this will be 1 into square root of k tangent inverse of u by square root of k plus c. Now you can make this nicer, and you can put the square root of k inside of this b, so it becomes square root of bk into tangent inverse of that, and finally you can get a and root bk tangent inverse of u, which is our square root of b x to the power n by square root of k plus c. And of course you can also make this inside nicer by writing square root of b by k, but I'm just going to leave it here and start off with our case 2. Now minus, so it will be a n root b integration of du by u square minus square root of k whole square. Again here we'll have to use another formula where I'll just write the answer directly. For these sorts of situations or these sorts of integrals, these special integrals, there's a formula. it is equals to 1 by 2 into whatever this constant is, square root of k, log natural of this variable minus that constant by the variable plus the constant plus c, and we can just replace u in the x. This will be 2 and square root of bk log natural of square root of b x to the power n minus square root of k by square root of b x to the power n plus square root of k plus c, and that concludes our general solution. Well, it should be general solutions because there arises two cases, but this is it, and if you learn something new, please like and subscribe. Thank you.